students, myself Om Prakash Katte and you are welcome to Biology Reward. Today we are discussing the class 12 Biology chapter Molecular Basis of Inheritance, and our topic is Meselson and Stahl experiment. So Meselson and Stahl experiment, it is very important experiment, and it's the evidence. Experimentally, they have given the evidences that the DNA replication is semi-conservative replication. So now, before proceeding to the Stahl's and Meselson experiment, we should know first one, semi-conservative DNA replication. Students, as a word is given, semi-conservative DNA replication. Regarding the DNA, the Watson and Crick, they said that the DNA molecule is the helical molecule where two polynucleotide chains are coiled to each other, and this is called double DNA helix, or DNA two chains are coiled with each other. So it is proposed DNA double helix structure by the Watson and Crick. After that, the Watson and Crick said that these two strands of DNA get separated from each other. So when two strands of DNA get separated from each other during the DNA replication. So DNA replication, what we have learned? We learned that the strand of DNA, they separated from each other, and here the new strands of the DNA are synthesized. So when new strand of DNA is synthesized, it means there is a one parental strand. It is the parental strand, and other is a new strand. This one, second one is a new strand. So if there is one parental and one new strand, so this type of replication of DNA replication is called semi-conservative replication. Here also, one is a old strand, it means parental strand, and another is a new strand, it is also semi-conservative replication. So Watson and Crick, they have given the proposal, or they explained that the DNA replication is semi-conservative replication. So semi-conservative is what? It means here is one parental strand. This is the one strand, parental, and other strand is a new one strand, and this replication is called semi-conservative replication. So this semi-conservative replication of DNA, the experimentally proved by the scientists. One is called the Meselson, and second is Franklin Stahl. So commonly this experiment is known as the Meselson's and Stahl's experiment, and they gave it in 1959. Okay. So thus, what is the Meselson and Stahl experiment? By this experiment, both scientists have proved that the DNA replication is semi-conservative DNA replication is proved by the Meselson and Stahl. Now, first one, Meselson and Stahl, they took the E. coli bacteria. This E. coli bacteria is having its own DNA, and this bacteria, they grown in medium containing NH4Cl ammonium chloride, and this nitrogen is heavy molecular nitrogen. So E. coli grown in the medium containing NH4Cl. Here nitrogen molecules is the heavy molecule. Two forms of the nitrogen occur. This is nitrogen 14, it is the radioactive substance, and one is the nitrogen 15, it is the non-radioactive substance. But nitrogen 14 is the light, less density, and nitrogen 15 is having the heavy molecule of the nitrogen, which is having the more density. So nitrogen 14 and nitrogen 15 can be separated by cesium chloride, calcium not, cesium chloride gradient. So first one we should understand, there are the two isotopes of nitrogen. Nitrogen 14 is the light and it is radioactive molecule, whereas nitrogen 15 is a heavy molecule, and these both nitrogen 14 and 15 can be isolated or separated by cesium chloride gradient. So what happened? First one we should understand, the Meselson and Stahl, they have taken the E. coli, and this E. coli is having own DNA, and they grown this one. These are grown in the medium containing NH4Cl. So what happened? The nitrogen 15 is lined with the DNA molecule. So this nitrogen 15 and 15 will come in the DNA molecule of E. coli. Now, this DNA molecule of E. coli is having the N15 and 15, it transfer to medium. It transferred to medium containing NH4Cl. It is N is 14. Now what happened? First they grown the E. coli in the medium containing NH4Cl having nitrogen 15. Then this DNA, this nitrogen come in the molecule of DNA. Then this one is transferred to the medium containing NH4Cl. So when they transfer to the medium, what they observe? This is the one strand of DNA. It is N50. And this is the another strand of the DNA. It is the N40. So this type of DNA is obtained. When it is obtained? When E. coli first grown in the medium N15 NH4Cl, then it's transferred to the medium containing NH4Cl. So this nitrogen will come and mix with this DNA molecule, and that's why now to see first one, this is the DNA molecule N15 and N15. This N15 and N15 come when the E. coli grown in the medium containing NH4Cl 15. Now what happened? This is transferred to the medium. Which is the medium? NH4Cl. It is having 14. So after 20 minutes, why we are writing 20 minutes? Because the replication in E. coli occur in 20 minutes. So after 20 minutes, this one combination is active. What is the combination? One strand of N14 was N15 was there, and another strand here, this one new strand I am labeling. So one other strand is labeled is the N40, because first one it is grown in the medium N50, but now it is transferred to medium N40. So one strand is labeled with the N50. It means here the results came in after 20 minutes, 100% of progeny or DNA are hybrid. Hybrid DNA, it means N15 and N14 is one strand is N50, another strand is N14. When after 20 minutes. But when second generation, it is result of the first generation. But to write in first generation, E. coli grown in the N50, then it transferred to the N14. Then what happened? In F1 generation, first generation, we are getting the DNA is having 100% are hybrid. It means one strand is 9 N15, another strand is N14. So this type of one more strand I have to make. So 1 N50 and it is the N40. Now after the 20 minutes, second generation, it means 40 minutes. After 40 minutes, what they observe? There were these strands N14 light strand and N14 light strand, Similarly, here this was the N14 and this N15. N15, this is N15, 14, this stand is N15. Similarly, this one more stand, it is N14 and this is N15. What happened? After 20 minutes, 100% of the DNA are hybrid. But if second generation, after 40 minutes, again next 20 minutes, it means after 40 minutes, second generation, what happened? 50%, these are the light stand, 1, 2 are light stand, light DNA. And 50% are the mixed hybrid DNA. Okay. So what is proved here? It is proved that if there is the strand of DNA, one strand of DNA is newly synthesized. One is the parental strand and one strand is newly synthesized. Here also you see these and these, nitrogen 14, nitrogen 14. Okay, these are the radioactive DNA. But if you will see this one, in this case, one strand is parental strand, another strand is new one strand, N40. Here also N15 and N40. So what happened if after 20 minutes, all the 100% of the DNA are the hybrid DNA, but in 40 minutes, you will see here 50% are the light DNA and 50% are the hybrid DNA. If you will go for the next generation, suppose after 80 minutes, so after 80 minutes what happened? The light DNA, this will be light DNA, it will be 75%. And hybrid DNA, the hybrid DNA will be 25%. It means, once if you are passing to one generation to next generation, the percentage of hybrid DNA is decreasing. After 160 minutes, what happens? 25 divided by 2, so 12.5. So your 75 plus 12.5, that will be 87%. 87.5% will be light DNA and 12.5% will be the hybrid DNA. So listen here, the Meselson and Stahl, what they have proved? They have proved that DNA replication is a semi-conservative DNA replication. First they grown in the E. coli in medium containing N15, NH4Cl, nitrogen is N15, then it is transferred. So DNA is labeled with the N15. Then they transferred it to the medium containing NH4Cl where the nitrogen is 14. It means it is radioactive nitrogen. This both can be separated by cesium chloride gradient method on basis of their density, because N15 is having the more density and N14 is less density. Now, when the DNA grown in the medium N15, so DNA is labeled with N15. Then they transfer to the medium NH4Cl having N14. So after 20 minutes is a lifespan of the E. coli. So after 20 minutes, what we are getting? This 100% of DNA are the hybrid DNA. It means one is the parental strand and one is a new strand. So it is called semi-conservative replication. But in second generation, after the 40 minutes, here 50% hybrid DNA comes and 50% light DNA. But if you will repeat for the third generation for 80 minutes, then light DNA will be 75%, whereas hybrid DNA is 25%. And next generation also is. So this Meselson and Stahl experimentally proved that the DNA replication is a semi-conservative replication. It means there is a one parental strand and another is a new synthesized strand.